Hi there. Thank you for clicking on this video. Today we're talking about absolute value equations. Please like this video if you find it helpful, subscribe for more math content, and check out the practice set for this lesson as well as other videos on the channel. Now, I don't know when you are watching this, but for me, we are heading back to school in my district over the next day or so, and I haven't been able to upload as much as I was over the summer because obviously I've got a lot going on. So if you're perusing the channel and there's something specific that you're looking for your class and you can't find it, drop a comment on this video. Let me know what it is that you are looking for, and I will try to point you in the right direction or record something new. So we want to start off talking about what is absolute value. And if you're watching this as an Algebra 2 student, probably you have encountered absolute value. If you're in Algebra 1, maybe you haven't, maybe this is the first time you're seeing it. Either way, we want to go over what the symbol is and what does the symbol mean. The symbol for absolute value is two vertical lines. And then I'm going to use a really high-tech advanced math word. There's some stuff in between those two vertical lines. Now, when you're writing the absolute value symbol, you do want to make sure that you make your vertical lines taller than, say, the number 1. So you want to make sure you can kind of look down here where we have the absolute value of 3. You want to make sure that the way you're writing it doesn't look like the number 131. Okay, so they're two vertical lines. Now, what do they mean? Okay, these two vertical lines literally mean the distance from 0 on the number line. Okay, and I used to just say the distance from 0 and then realize that in my head, I'm picturing the distance from 0 on a number line, like that's what I mean. And that many of my students weren't picturing that, like the distance from 0 didn't mean much. So it means the distance from 0. So something like this. Okay, we could read this out loud, the absolute value of 3. But we could also read it as the distance of 3 from 0, or how far is 3 from 0. And that's just invoking the definition of what that symbol means. So if we look at the number line here, here's the number 0. Okay, here's 3, and essentially what we're asking is how far away is it? What is that distance? And I've had students do different things here, but you want to count essentially the spaces. So if you were to walk from 0 to 3 or 3 to 0, how many spaces or steps would you be taking? And so you're looking at, like, here's 1 unit. Okay, that's like 1 step away. Here's 2 steps away, and here's 3 steps away. So you're counting the spaces, not the lines. That is something that I have seen students do before. And so the absolute value of 3 is 3, meaning it is 3 units away from 0 on the number line. Again, invoking the definition. So now we get to the absolute value of -3. So here's 0, here's -3. Again, it's how many steps would you be taking? Okay, to get from 0 to -3 or from -3 to 0, how many steps would you have to take? What is that distance there? Well, it's 1 unit, 2 units, 3 units. And so the distance of -3 from 0 on the number line is 3. And what you want to notice here is that the direction you're going from 0 does not matter. Now, there are math problems where direction does matter, okay? Even when we're just subtracting numbers and we're counting on the number line, the direction we're counting matters, okay? If we're subtracting, we're moving left. If we're adding, we're moving right. With absolute value, the direction doesn't matter. It's just how many steps. If you're standing on the 0, okay? So this is, here, erase that. All right, so if you're standing, here's you, this is you, okay? All right, there you are. Standing on the 0, how far would you have to walk? So if you've got like maybe one of the watches, that fitness watch that tracks your steps, well, the fitness watch does not care whether you're walking north, south, left, right, up, down. Like, it just logs how many steps you're taking. So that might be a helpful analogy for you, just to think absolute value is counting, like, how many steps do I have to walk? Now, one special case with absolute value is the absolute value of 0, and that is a thing. Okay, so if you are standing on the 0 and somebody says, what's the absolute value of 0, or what's the distance of 0 from 0, or how far do you have to walk to get to 0 from 0? Well, the answer to that is 0. Okay, the absolute value of 0 is 0. You don't have to walk anywhere. Okay, so that's the definition, the symbol, and hopefully gave you a concept. Okay, I've had students come into my class and they're like, well, absolute value just means you get rid of the negative sign. Well, like sort of, but we want to know why. Why does absolute value get rid of the negative sign? It's because it's the distance from 0 and the direction does not matter. Absolute value is always non-negative. Okay, and I've heard people say absolute value is always positive. No, it's not always positive, and here's why it's not always positive. It's that right there. That is the reason why it's not always positive. It only takes one case for it to not always be positive, but it is always non-negative, and it's often used when we need to avoid negative results. So if you have some kind of situation where a negative doesn't matter or it doesn't make any sense, or where you are looking for a distance away from something, absolute value like pops up in those kinds of problems. It's not real common, but it does come up. So how do we reason through equations? Okay, so now that we've gone over like what is absolute value, how do we reason our way through? So we're going to start by looking at the most basic absolute value equations we can have. The absolute value of x is equal to 5, and we're looking for what is the value of x. Okay, so we know it's an equation because we have an equal sign, and we know it's an absolute value equation because there's absolute value there. So what this means, okay, so we want to translate this verbally, is sorry, let me reboot that. I can do better than that. Okay, x has a distance from 0. You could say of 5. I would say of 5, but you could say a distance from 0 equal to 5. In other words, you start at the 0 and you're going to walk 5 steps. Okay, now what the absolute value doesn't care is which direction you walk. So you could start at the 0 and walk 1 step, 2 steps, 3 steps, 4 steps, 5 steps. Okay, or you could go the other way, 1 step, 2 steps, 3 steps, 4 steps, and 5 steps, and you could be there. Both of those numbers, 5 and -5, have a distance from 0 of 5. It's just like, which direction are you going? So we would say the solution to this is x is 5 and x is -5. Both of those numbers make the equation true. Okay, so if you were to plug in the absolute value of 5 is equal to 5, true. I'll show you what I'm talking about. If you were to plug the number into check, okay, absolute value of 5 is 5, 5 equals 5, that's true. You could also plug in the -5, absolute value of -5 is 5, and that is also true. And so both of those numbers make the equation true, which means both of those numbers are solutions. Next one. We've got the absolute value of x is equal to 0. And so what we're saying there is that x has a distance from 0 of 0. Well, there's only one number that has a distance of 0 from 0, and that is 0. And so the only thing you can plug in that will make that equation true is 0. And then the last one is the absolute value of x is equal to -5. Well, here we have a bit of a problem, okay? So we're saying x has a distance from 0 of -5. But here's the problem. Distance can't be negative. Okay. And again, I want you to think back to your fitness watch that tracks your step. There's nothing you can do during the course of the day that's going to cause your fitness watch to subtract steps from your total. Like there, you can't walk a negative distance and it's like, no, we're just going to get rid of those steps. And so this one, we say there is no solution. There is no value of X that you can plug in and get a -5 out. Okay. So when you're dealing with an absolute value equation, what we want to get from this slide here is that you can have two solutions, you could have one solution, and it's also possible that you have no solutions. There is nothing that will make the equation true. I would say most absolute value equations do have two solutions because that's all of your positive numbers. And you just don't see the ones that come up with like the negative that often. Usually when we're just starting to introduce this and we want you to pay attention to it. But once you kind of get out of that first piece of your absolute values, you're not really going to see the last case there. All right, so we're going to make it a little bit more interesting because that was fun, but we can do better. So this one is a more complicated equation. We have the absolute value of X plus 3 is equal to 5. And we want to interpret that in our head using the definition. Okay, we are not memorizing a process, okay, that is not going to serve you well in the long run because you're going to forget the process. So we want to interpret it. What that statement means is X plus 3, that's the thing inside the absolute value, okay? It's the thing you're taking the absolute value of, has a distance from 0 of 5. Okay, again, we're using that definition. So instead of just X has a distance of 0 from 0 of 5, we have X plus 3 has a distance from 0 of 5. Well, here's our 0. Okay, so here's you. And we're talking about that distance from 0 being 5. So we know that we can go 5 to the right, or we could go 5 to the left. So we've got two possible situations there. Well, what is it that has a distance from 0 of 5? It's X plus 3. So instead of X being at the 5, it's X plus 3. X plus 3 is the thing that has the distance from 0 to 5. And then we could also have the X plus 3 over there has a distance from 0 to 5. Now, what that means is that this expression and this expression both become their own equations. So X plus 3 could be equal to -5, or X plus 3 could be equal to 5. Either of those will work. Okay, so X plus 3 could be the -5 or the 5. And then you just solve these as is. So we would subtract the 3, -5 minus 3, or you might say -5 plus -3, okay, is -8. And subtracting 3 here, we get X is equal to 2. And just so you can see, okay, if I take my first solution, so here's my equation, and I plug in -8. -8 plus 3 is -5, and the absolute value of -5 is 5, and note that that is true. The other solution also works. So if I plug in a 2, 2 plus 5 is 5, and the absolute value of 5 is 5, and once again, it is true. Now, I would not expect you to check every answer, but we don't want to lose sight of what it is that we're doing. We're finding the value of the variable that makes the equation true, and both -8 and 2 will result in a true statement. Now, we drop the absolute value symbol once we split the equation because we take it when we consider the distance from 0. So if you're like, well, wait a minute, what did you do with the absolute value? Why are the absolute values gone? Well, this process right here, where where we're like analyzing this, we're like thinking, what does the absolute value mean? When we're doing that, we are actually taking the absolute value. So we're doing that process of the operation there when we split it. A common mistake that I see students make is that they have absolute values around the equations here. But remember, if you put absolute value here, like that's the same problem you started with. If you put absolute values in here, you actually are writing something impossible because that absolute value can't be negative. So you do want to make sure that that step there is where you're dropping the absolute value. All right, so I want to look at a few more variations of what you might see. So what can we do to make this a little bit more difficult? So this is the distance of zero, distance from zero of x minus 2. Or x minus 2 has a distance from 0, okay? But then you take that distance and then you add 6 to it. And when you add 6 to the distance from 0, then you get 10, okay? It's like a little bit weird. So we have a distance from 0, and then we add 6 to that distance, and then we end up with 10. So the way we want to start this is like that plus 6, that is throwing off the whole distance from 0 thing, okay? Distance from 0 and then add 6 to it. So what we want to do first on this one is we want to get rid of that adding 6, okay? That adding 6 is cramping our style. So if I subtract 6 from both sides of the equation, 6 minus 6 is 0, 10 minus 6 is 4, and now I've got something that makes more sense. X minus 2 has a distance from 0 of 4. Now, you don't have to do the number line. But if you do, okay, because it's visual, is plunk your number line down, put the 0 there, and then say, okay, the distance from 0 is 4. So we know we can go 4 in either direction. We can go 4 to the right or 4 to the left. And what has the distance from 0 of 4? It's the x minus 2. Okay, you don't need to do out like a big detailed number line. And right here, that gives us one of our equations. X minus 2 is equal to negative 4. Here's my other equation. X minus 2 is equal to 4. And these ones we would solve by adding 2 to both sides. Negative 2 plus 2 is 0. Negative 4 plus 2 is negative 2. And here we get 4 plus 2 is 6. And so there are solutions, and we can do a quick plug-in. Negative 2 minus 2 is negative 4. The absolute value of negative 4 is 4, and 4 plus 6 is 10. 6 minus 2 is 4. The absolute value of 4 is 4, and 4 plus 6 is 10. So we're sure we got those right. But you do want to subtract that 6 first, or like if it were minus 6, you'd want to add it. Like we can't really use the definition, distance from 0, while we have other stuff going on. Another variation that you might see is this. This is 3 times the absolute value. So it's 3 times the distance is 12. Now, you'll see I have written over there on the right, don't distribute through the absolute value. So I do see a lot of students do this. Okay, don't write this down, where they distribute through and they'll work with that. Okay, and it's a tempting thing to do because you're like, okay, I dealt with that 3. The problem is that it doesn't work if the number you're multiplying through is negative. So right there, we have like a positive 3 and we're multiplying it through, and it's actually okay. But if it were a negative 3, we would have an issue because the absolute value, of course, when you take the absolute value, it does away with the negative. The absolute value can't be negative. And so it will cause an issue. So I usually discourage my students from doing that at all. Now, so then you think, well, what am I supposed to do with the 3 if I'm not allowed to distribute it? If it were another kind of problem, you'd say distribute. If it was parentheses, and yes, I would. But remember, this is multiplication. So to undo multiplication, we divide. Right there, 3 divided by 3 is 1. And 12 divided by 3 is 4, and now we're in a position where we can deal with that. So once again, you don't have to do the number line, but if it helps, go for it. We have 4s again. I don't know why that was by accident that we ended up with 4s. But the distance from 0 is 4, does not matter the direction. it is x plus 2 that has that distance from 4. So we can have x plus 2 equals negative 4, and x plus 2 is equal to positive 4. Both of those will work. We subtract 2 from both sides. 2 minus 2 is 0. Negative 4 minus 2 is negative 6, or you could think of it as negative 4 plus negative 2. And subtract, and we get 2. And once again, you can go and plug both of these into the original equation, and you should be able to see that you have a true answer there. So those are the variations, and you can see these combined, so you can see something that has something added as well as something multiplied. You would solve that by undoing the adding or subtracting first, and then the multiplication. Check out the practice set. I've got a couple in the practice set like that. So check those out. All right, now this is a cool student observation. This is a completely true thing. It did not happen in my classroom. It happened in a colleague's classroom where we were teaching absolute value equations, and a student who this might sound kind of weird, but this was not like a student that probably thought they were very good at math. Okay, so if you're picturing, oh, well, this is like the AP calculus guru, you know, the top kid in the school. No, like this is a student that I think took a risk. So recall this: if you have y equals the absolute value of x plus 5, when you add 5 inside a function, it shifts the function left. Okay, so it's going to make the graph slide to the left 5 units on the number line, so or on the coordinate plane. Just move it left. So this student, having studied transformations, and then the teacher introduced absolute value equations. I think it was actually absolute value inequalities, but it works for both. So now consider this equation. So the way that I just kind of went through it, you would think, okay, the distance from 0 is 9. Now, what this student did, though, this student made it visual. And so this student said, okay, here's the 0, and the distance is 9, okay? So that means that the x plus 5 could be 9 or negative 9. This student, instead of setting up the equations, okay, and then thinking about inverse operations, so I undo adding with subtracting, this student thought about it in terms of transformations and said, okay, well, if I know that this would take the function, the graph of the function, and slide it left, can I take these 2 points and slide them left? 1, 2, 3, 4, 5, okay, which would put us at 4. So x is equal to 4, and then do the same thing over here. 1, 2, 3, 4, 5, and x is equal to negative 14. Now, sliding to the left, if you remember, well, if you're doing this for Algebra 2, you might not have worked through all my Algebra 1 videos. And I think they're also in pre-algebra where we talk about subtracting, and subtracting on the number line means counting or moving to the left on the number line. And so that is literally the process you would do here if you set it up as x plus 5 equals negative 9, x plus 5 equals 9. Well, what you would do is you would subtract 5, which means you would be sliding on the number line to the left. And so I thought it was one of those things that as a teacher, like you have to stop and think and like, okay, this just connected some stuff. It connected our transformations with the process of subtracting and the idea of sliding left, which also makes the idea that adding 5, sliding it to the left, like it makes sense in another way because you're connecting it. But it was really, really neat that a student connected those ideas, and the way that student was processing this whole thing was sliding on the number line instead of setting up the equation. So, and this was several years ago, and we're still talking about it as teachers as like insight that the student had. And so all of that just to say, always share your insights and your thoughts. If you think you're seeing a pattern, if you see a connection, and it looks like something else you did, ask, like speak up. I mean, sometimes it's connected, sometimes it's not connected, but it's always worth it to share those insights and thoughts. And hopefully your teacher appreciates that and explores those. I mean, I know I would, if my student said, hey, is this related to this other thing that we studied? So that made the video go a little bit longer, but I hope you thought it was interesting. Please don't forget to like and subscribe for more math help. Drop a comment or question below to engage. Check out the practice set for this lesson, as well as the other playlists and videos we have on the channel. And hopefully I'll see you in a future lesson.